So for the next two problems, we're going to look at solving some differential equations to generate general solutions. Now, if it's a general solution, it means that we're going to have some constants in there. We'll later look at some questions where we have particular solutions where we can actually work out what those constants are, where they'll have some kind of value for a specific situation. Now, the key with all differential equations is basically you need to isolate your variables onto one side and the other. So in our case, if they're in terms of x and y, like these two problems are going to be, we want to get all of the x terms on one side, all of the y terms on the other. Sometimes it's a little bit easier, sometimes it's not, but it's all about algebraic rearrangements, okay? So if your algebra is good and your rearrangement skills are good, this should be okay. So let's have a look at the first problem then. This is about as nice as it's going to become. Well, if we want to move the x's so that they're on their own, well, the x and the dx are currently dividing on this side. So when they move up to the numerator. So you get x dx. And this y squared over 2 is the divide on this side. So when it moves, it becomes a multiplication. So we have y squared minus 2 dy. And that's it to start with. We just separated our variables. Y is onto the left, x is onto the right. Now, you might spot we have our dy's here. Well, we don't really want these. So how are we going to get rid of them? Well, we're going to use integration. And we're just going to integrate both sides of our expression. So we're going to integrate them. And these are quite nice to integrate. Y squared, when we integrate with respect to y, raise the power by 1 becomes 3, divide by the new power, so divide by 3. The minus 2 is going to become minus 2y. And we will generate a constant of integration, but I'll deal with that in a second. Let's have a look at the right-hand side then. Well, when we integrate x with respect to x, raise the power by 1, 2, divide by the new power 2. And again, we'll generate a constant of integration. Now, because both of these will have constants, you don't actually need to write a constant on each side. We're fine to just put a plus c on one of the sides, typically the right-hand side, as that accounts for both this constant and this constant. For example, if that was 5 and 10, moving the 5 over, 10 minus 5, you'd be left with 5. So it accounts for both constants there. And this will play true as well when we look at the particular solutions later. And actually, that's all there is to it for the first problem. We've integrated both sides, we've got our constant, and that is a general solution. Now, it might ask for a specific form, but for this question, you'd be perfectly fine to leave it like that. So part B, a little bit more work to do, but it's the same type of process. Again, we need to get the x terms on one side, y terms on the other. So let's move this minus x squared first. 2x squared y dy by dx is equal to x squared plus 1. Well, we can divide by the x squared, and this dx can move and become up into the numerator as a multiplication. So you're left with 2y dy is equal to x squared plus 1 all over x squared times dx. Now, let's simplify this expression a little bit. So really, we can say we have 2y dy is equal to x squared over x squared is just 1, plus, well, it's 1 over x squared, but as you can probably guess, we're going to be integrating in a minute. So we can really write that as plus x to the minus 2 dx. So we've isolated our terms, we've got them in a nice usable form. Now what we need to do is integrate both sides. So when we integrate 2y with respect to y, you get 2y squared over 2, which simplifies to y squared. The 1 integrates with respect to x to become x, and the x to the minus 2 becomes minus x to the minus 1. Okay, raise the power by 1, divide by the minus 1. It's going to change that sign. And you can't forget, we need a plus c there. Now, again, this would be fine as the final form, but it might ask you to make it y the subject. And if that's the case, all you need to do is square root that expression. So y is equal to the square root of x minus, now you can leave it as x to the minus 1, or write it as 1 over x plus c. And quite often I quite like it in fraction form. It's quite nice at the end, and it might be more useful if you're going on to do something later with it. But either form would be fine unless it wants y the subject, in which case you'll be looking for that last form there.